Hi, this video is for section 7.3 in Algebra 1. We are going to be working on multiplying polynomials using the area model. Now, the area model is simply an organizational tool. You can see it right here. And you look at a problem, it's simply just meant to help you make a problem like this easier, where you have some invisible math of multiplication there, and you have a binomial, which is a polynomial, times a binomial, which is another polynomial. It helps you multiply together so you don't miss anything. I really strongly believe if you follow this area model for multiplying polynomials, you're going to get your answers right. Let's review a little bit of vocabulary first. If I gave you an expression like, I don't know, 3x squared plus 5x to the fourth, it's important that you remember the numbers out front that are multiplying the variable, in this case the 3 and the 5, those are called coefficients. I'll be using that word in the videos a lot today. And then here, the 2 and the 4, hopefully you know and can remember those are called exponents. Ooh, that's quite bright green. I hope you can read that. So I'll be using the term exponents a lot, referring to the exponents. And then lastly, just the whole idea of the 3x squared or the 5x to the fourth, those are considered terms. The terms are separated out by this addition sign right here. There could also be a subtraction sign right there to separate out the terms. So I'll be using the word coefficient to refer to the numbers in front of the variables. I'll be using the term exponents to refer to the exponents, and I'll be using the word terms, where it's the grouping of stuff that are separated by addition and subtraction signs. We've been spending some time adding polynomials together, like you can see on the example at the left. Today we're going to transition into multiplying them together. The rules are different, so you want to pay attention and kind of keep track of what it is you're doing. Like we worked on yesterday, when you add polynomials, you simply add the coefficients together. 3x plus 2x equals 5x. You add the coefficients when adding or subtracting polynomials. The big thing to remember that we have talked about is that in order to add polynomials together, they need to have the same base. So here the bases are both x. There's some invisible math going on where it's x to the first power, x to the first power. So since they are both x to the first power, they are like terms, we can combine them. The rules for multiplication are a little more relaxed, I would say. When you have multiplication, all you do is you multiply the coefficients. 3 times 2 is 6. And then you add the exponents. So remember you add the exponents. So remember there's some invisible math here. These are really x to the 1, x to the 1. Well, 1 plus 1 is 2. So you end up getting 6x squared. So rules for multiplying polynomials. You multiply the coefficients. That's why we did 3 times 2 and got 6. And you add the exponents. That's why we did 1 plus 1 and got 2. So be really careful to remember that when it's an addition problem, you need the same bases and all you do is add the coefficients together. When it's a multiplication problem, you multiply the coefficients and then you add the exponents. Here's another one, addition versus multiplication. You look here. The expression on the left wants you to add. You know it's an addition problem because of the addition sign here. And now I look and I think, okay, what are the bases? I've got an x to the third and an x squared. So I actually, because the bases aren't the same, I can't do anything. So when we're asked to add something where the bases are different, that's all you can do. I can't do anything. because we need like terms. The bases have to be the same. It would have worked if they were both like x to the 3 or both x squared, then we could have combined them, but they weren't. All right, and then we go over now to multiplication. We remember the rules aren't nearly as strict, so all we have to do is multiply the coefficients. 5 times 2 is 10, and you add the exponents. 3 plus 2 is 5, so you end up with 10x to the 5th. So remember, rules for multiplying. Multiply the coefficient. That is, those are the numbers out in front. So multiply the coefficients. 5 times 2 is 10. And then we added the exponents. So the exponents, oops, let's pick a different color. The exponents were the 3 and the 2, so that's why we added 3 plus 2 to get 5. Now we're ready to look at that area model, the organizational tool that will help you so much. This problem looks a lot more complicated. I know I've got multiplication because of my multiplication sign right here. I know I have one term here because nothing's separated by an addition or subtraction sign. And I have one term over here because nothing is separated by an addition or subtraction sign. So I have a monomial times a monomial. So since it's one term by one term, my area model will be pretty straightforward. I just need room for the first term on the side and the second term on the top. And I believe I actually see a typo here. This x should be a z. I apologize about that. This x should be a z. That looks really messy. Can I quickly fix that? Kind of quickly. So 5x squared yz. So a one term times a one term, all we need to do is multiply the two together. So we do that fairly simply. The coefficient out in front and the coefficient out in front will multiply together. So 5 times negative 2 is negative 10. And then what I'm going to do is take the x's, x squared and x to the first, and that's when I'd add my exponents. So I'd get 2 plus 1 is 3, x to the third. What comes next are the y's. I've got a y right here and y to the fourth. This is really y to the 1, y to the fourth. So if I add those exponents, that gives me y to the fifth. And then to finish with the z's, I have z to the first times z to the first. You add those exponents and you get a z squared. So your final answer here is a negative 10 x to the third y to the fifth z squared. The whole goal was multiply those coefficients together, 5 and negative 2, and then it's kind of like you're combining up like terms. The x squared and x becomes x to the third, y to the first, y to the fourth becomes y to the fifth, and then z times z is z squared. Let's try another one. This one's a little more complicated. I have my multiplication is right here, so I have a monomial, which has one term in it, times a binomial, which has two terms in it. So my rectangle or my area model will look a little bit different. I'm going to put x to the fifth out front. And then on the top, I'm going to separate the two terms. So I have a 2x cubed and then plus a 3x squared. Remember that plus sign separates it into two terms. So when I make my area model this time, now I have two different slots. So let's start by looking at this one right here. I'm going to multiply the x to the fifth and the 2x to the third. There's definitely some invisible math here with a 1 in front. So let's go ahead and multiply the coefficients of 2 times 1 to get 2. And then x to the fifth times x to the third. You add those exponents together and get x to the eighth. Now let's try again for this open cell. So we're going to do 1x to the fifth times 3x squared. Well, we will remember that we multiply the coefficients. 3 times 1 is 3, and then you will add the exponents from the same base. So x to the 5th times x squared is x to the 7th. And it was a plus. So my final answer here I'll have is 2x to the 8th plus 3x to the 7th. You put your cells back together again. So your final answer is right here. Let's try another. This is our last one for the day, so stay with me. Now the whole goal is multiplication. I have multiplication there. I have one term, 8r squared, times a polynomial that has 3 terms. Remember, they're separated by, the terms are separated by that negative and that positive. So my goal is this 8r squared needs to multiply with everything inside the parentheses. So some teachers have taught an idea where the 8r squared has to multiply with all 3 terms. We'll set up your area model and you'll have no trouble. So the 8r squared goes on the left. It's going to be a long rectangle because I have to split it up into 3 parts for all 3 terms. All right, so now if we look at the first one right here, this first cell, we're going to do 8r squared times 4r squared. 8 times 4, you multiply the coefficients. 8 times 4 is 32. And then r squared times r squared, you add those exponents and get r to the 4th. Now I'm going to work on this second cell, 8r squared times a negative 5r. Well, 8 times negative 5 is negative 40. This really has r to the 1st power, so r squared times r to the 1st is r to the 3rd. And then to finish, this last cell right here, we're doing 8r squared times 7. Well, 8 times 7 is 56, r squared, and then there is no r here, so it'll just stay r squared. So then to finish, we put our cells together, 32r to the 4th minus 40r cubed plus 56r squared would be your final answer. So I can't recommend highly enough using the area model when you do your worksheet homework tonight. The work you can show is your rectangles. So we'll be looking for in your work to see the problems. Maybe you'll need an area model like this or just like this, or maybe the one example you just needed one. But there are 6 problems to practice this and get really good at it. Reach out to your teachers if you need some help. Thank you so much. We appreciate your efforts, and we'll talk to you soon.